The recommendation to install watertight receptacles and circuits in a baptistery, even if water is not expected to contact electrical equipment, is potentially misleading. While a baptistery is a high-moisture environment, the NEC, or National Electrical Code, doesn't automatically mandate watertight components unless the area is classified as a wet location. Installing such components unnecessarily could lead to increased costs and installation complexities. The recommendation doesn't inherently violate NEC Section 250.114, which deals with grounding and bonding in wet locations. That section doesn't specifically address baptisteries. The key is whether the location is considered wet. For electrical installations in baptisteries, adherence to NEC Article 406 is crucial. Article 406 provides requirements for receptacles, cord connectors, and attachment plugs. If there is a likelihood of water contacting electrical equipment, then watertight receptacles and circuits are required. If the chance of water contact is minimal, then standard receptacles can be used. Here's a breakdown of how to approach this topic. Firstly, determine if the baptistery area around the electrical equipment is classified as a wet location according to the NEC definition. A wet location is defined as an area subject to saturation with water or other liquids, such as locations exposed to weather, washdown areas, and some interior locations. Secondly, if the area is deemed a wet location, then use receptacles that are listed for wet locations, along with appropriate covers. Thirdly, if the baptistery area is not a wet location, regular receptacles are acceptable, but ensure they are still protected from moisture as much as possible. Consider using weather-resistant receptacles. Fourthly, all electrical circuits in the baptistery must have ground fault circuit interrupter protection, also known as GFCI protection, as per NEC requirements for areas where shock hazards are present. This includes receptacles and lighting circuits. Fifthly, ensure all electrical equipment is properly grounded and bonded according to NEC Article 250 to minimize the risk of electrical shock. Sixthly, regularly inspect electrical equipment and wiring in the baptistery for signs of damage or deterioration. Replace any damaged components immediately. Seventhly, ensure all electrical work is performed by a qualified electrician who is familiar with the NEC requirements for wet and damp locations. Eighthly, train personnel who operate or maintain electrical equipment in the baptistery about electrical safety and potential hazard. When assessing if a baptistery is a wet location, consider the following: the likelihood of water splashing or spraying onto electrical equipment during baptisms, humidity levels in the baptistery and the potential for condensation to form on electrical equipment, whether the baptistery is regularly washed down or cleaned with water. Based on these factors, determine the appropriate level of protection for electrical equipment and select components accordingly. Article 406 of the National Electrical Code provides guidelines for receptacles in wet and damp locations. Section 406.9 covers receptacles in wet or damp locations. For wet locations, the receptacle must be within an enclosure that is weatherproof whether or not the attachment plug is inserted. For damp locations, the receptacle must have a weatherproof enclosure when the attachment plug is inserted. Furthermore, NEC Article 430 covers motors, motor circuits, and controllers. If a motor is used to circulate or heat the water in the baptistery, it must be suitable for the environment in which it is installed. If the motor is located in a wet location, it must be a motor specifically designed for wet locations. Also, it is critical to comply with NEC Article 680, which addresses swimming pools, fountains, and similar installations. Even though a baptistery is not exactly a swimming pool, the principles of Article 680 should be applied to minimize electrical hazards. This includes bonding all metal parts of the baptistery together to create an equipotential plane, which reduces the risk of electric shock. Proper bonding and grounding are critical for electrical safety in baptisteries. Bonding involves connecting all metal parts of the electrical system and non-electrical metal parts together to form a continuous electrical path. This helps to ensure that all metal parts are at the same electrical potential, reducing the risk of electric shock. Grounding involves connecting the electrical system to the earth, providing a path for fault current to flow back to the source. This helps to trip over current protection devices such as circuit breakers quickly in the event of a fault. Here are some best practices for grounding and bonding electrical equipment in baptisteries. Use a grounding electrode system that complies with NEC Article 250. Connect all metal parts of the electrical system and non-electrical metal parts to the grounding electrode system. Use listed grounding and bonding connectors. Inspect grounding and bonding connections regularly to ensure they are tight and free from corrosion. Ground fault circuit interrupters, or GFCIs, are essential for electrical safety in baptisteries. A GFCI is a device that detects ground faults, which occur when current flows through an unintended path to ground. Ground faults can be caused by damaged wiring, wet equipment, or contact with energized parts. When a GFCI detects a ground fault, it quickly interrupts the flow of electricity, reducing the risk of electric shock. NEC Article 210.8 requires GFCI protection for receptacles in damp and wet locations, including baptisteries. All receptacles installed within a baptistery should be GFCI protected. In addition to receptacles, consider using GFCI protection for lighting circuits and other electrical equipment in the baptistery. Test GFCIs regularly to ensure they are functioning properly. Press the test button on the GFCI. The GFCI should trip, interrupting the flow of electricity. Reset the GFCI by pressing the reset button. If the GFCI does not trip when tested, it should be replaced immediately. Proper wiring methods are essential for electrical safety in baptisteries. Use wiring methods that are suitable for wet locations, such as liquid-type flexible metal conduit, or LFMC, or rigid polyvinyl chloride conduit, or PVC. Avoid using non-metallic sheath cable, or NM cable, in wet locations, as it is not designed to withstand moisture. Support wiring properly to prevent damage. Protect wiring from physical damage. Use listed fittings and connectors. Regularly inspect wiring for signs of damage or deterioration, replacing any damaged wiring immediately. Electrical safety training is essential for personnel who operate or maintain electrical equipment in baptisteries. Training should cover the following topics: basic electrical safety principles, identification of electrical hazards, proper use of personal protective equipment, lockout-tagout procedures, emergency procedures. Personnel should be trained to recognize and avoid electrical hazards. They should also be trained on how to respond to electrical emergencies. Regular electrical inspections are essential for ensuring electrical safety in baptisteries. Inspections should be performed by a qualified electrician. Inspection should cover the following: condition of electrical equipment, condition of wiring, grounding and bonding connections, GFCI protection, compliance with NEC requirements. Any deficiencies identified during inspections should be corrected immediately. Creating an equipotential plane can significantly enhance electrical safety in baptisteries. An equipotential plane is a network of interconnected conductive elements designed to minimize voltage differences in an area. This reduces the risk of electric shock by ensuring that all metal parts are at approximately the same electrical potential. To create an equipotential plane in a baptistery, bond all metal parts together, including the following: metal water pipes, metal drain pipes, metal structural components, metal equipment enclosures. Connect the bonding network to the grounding electrode system. This helps to ensure that all metal parts are at the same electrical potential, reducing the risk of electric shock. Furthermore, lighting in a baptistery should be carefully considered to ensure both adequate illumination and electrical safety. Use lighting fixtures that are listed for wet locations. Install lighting fixtures in a way that minimizes the risk of water contact. Consider using low-voltage lighting systems, which reduce the risk of electric shock. Ensure that all lighting circuits are GFCI protected. Regularly inspect lighting fixtures for signs of damage or deterioration, replacing any damaged fixtures immediately. Lockout-tagout procedures are essential for electrical safety during maintenance and repair work. Lockout-tagout is a safety procedure that involves disconnecting electrical equipment from its power source and securing the disconnecting means with a lock and tag. This prevents accidental energization of the equipment while work is being performed. Develop and implement a lockout-tagout program that complies with OSHA requirements. Train personnel on lockout-tagout procedures. Ensure that all electrical equipment is properly labeled with lockout-tagout instructions. Use only approved lockout-tagout devices. Regularly audit the lockout-tagout program to ensure it is effective. Portable electrical equipment, such as extension cords and portable heaters, can pose electrical hazards in baptisteries if not used properly. Avoid using portable electrical equipment in wet locations. If portable electrical equipment must be used, ensure that it is listed for wet locations and GFCI protected. Inspect portable electrical equipment regularly for signs of damage or deterioration, replacing any damaged equipment immediately. Never overload extension cords or circuits. Unnecessary electrical equipment should be removed from the baptistery to reduce the risk of electrical hazards. Simplify the electrical system by removing any unused wiring or equipment. This can help to reduce the risk of electrical shock and fire. Implementing a comprehensive electrical safety program is essential for protecting personnel from electrical hazards in baptisteries. The program should include the following elements: electrical safety training, regular electrical inspections, lockout-tagout procedures, proper wiring methods, GFCI protection, grounding and bonding, emergency procedures. The program should be tailored to the specific hazards present in the baptistery. Review and update the program regularly to ensure it is effective. Emergency procedures should be in place to address electrical emergencies such as electric shock, fire, and equipment failure. Train personnel on emergency procedures. Post emergency contact information in a visible location. Keep a first aid kit readily available. Regularly review and update emergency procedures. This is to ensure they are effective. In summary, while the initial recommendation to install watertight receptacles regardless of potential water contact may be overly cautious and not strictly mandated by the NEC, prioritizing electrical safety in baptisteries is paramount. A thorough assessment of the environment, adherence to relevant NEC articles, particularly Article 406 and Article 680 where applicable, and implementation of comprehensive safety measures are crucial. These measures include proper grounding and bonding, GFCI protection, appropriate wiring methods, regular inspections, and comprehensive training for personnel. By taking a proactive and informed approach, one can ensure a safe environment while also avoiding unnecessary expenses.